Joe, did you see that they announced the title for the next Godzilla movie? Oh, that's crazy. Alright. Still don't know what that other trailer was with the green dude. That might be something else new coming, we don't know. Excuse me. Alright. 5-3, is that where we are? And what numbers did we do? 8 through 36. Number 8 is angle 4. Number 10 is angle 7 and angle 8. Number 12 is angle 2 and angle 5. Number 14 is angle W, angle Y, angle Z, and segments YZ, WZ, and WY. 18 is angle A, angle B, angle C, and segments BC, AC, AB. Obviously the order matters on those, because that's the point of the question. Number 20 is bend because of something, you don't have to write exactly these words, but something along the lines of using the triangle sum theorem that measures the angles across in the segment between Hannah and Gilberto is 70. Since 48 is less than 70, the pass from Hannah to Ben would be shorter. Number 22 is angle X, angle Y, angle Z, and then segment YZ, XZ, and then XY. 24 is angle 1, 26 is angle 7, 28 is angle 3, and 30, the measure excuse me, of angle ABD is greater than the measure of angle BDA. 32, the measure of angle BFD is less than the measure of angle BDF. 34, segment SM is, the measure of segment SM is less than the measure of segment MR. 36, the measure of segment RQ is less than the measure of segment PQ. We do 36 or 38? 36. Okay. I don't know why I didn't do 38, but that's fine. What questions do we have? What? 30. Okay. F. This is 12, this is 15, this is 11, 14, 3, and 13. This is 5. Obviously not drawn perfectly, but good enough to get us to the answer. Number 30 We are supposed to use that figure to determine the relationship between the measures of the given angles. We want to see which one's bigger. So angle ABD and angle BDA. Okay. This goes back to the very beginning, right? Making sure we understand how to name angles, right? The middle letter is the one where the vertex is. It's really important, right? So A, B, D would be this one, right? That's that one. And then angle B, D, A would be this one. So we're talking about the triangle ABD, right? And we want to know which one is bigger, the red one or the orange one, right? That's our goal on this problem. So what are we looking at when we're trying to figure that out? BDA is not bigger. That's the red one, right? The red one is not bigger than the orange one. ABD is bigger. How do I know that it's bigger? Because what? Because of 3 and 13. Right. That's exactly what I'm looking at. Right? 13 is across from ABD, right? 3 is across from ADB. Since this number is smaller, this angle is smaller. Since this number is bigger, this angle is bigger. Right? So the answer, real simply, is just the measure of angle ABD is greater than the measure of angle BDA, right? This lesson is a bit of a reprieve, right? It's a little bit easier. You're kind of going back to kindergarten math, but with pictures, right? Which number is bigger? Right? That's what we're kind of doing. What? What? No, because you might have something that may be confused or something. What are you thinking? What are you thinking? 13?
Was on that. That means BDA is bigger.
Okay, so so if I'm not like explaining like what you're saying, then we'll try again and ask in a different way or whatever. So you're looking at which one is across from it, right? So it's the one that's across from it, not the one next to it. So that one goes with that one, right? And this one goes with this one. And that's what you're looking at. Yeah. So you were thinking right, just looking at the wrong relationship. It's the one that's across from it, not next to. Does that make sense? Yeah, thank you. Good job. What other questions from this lesson do we have? 12. Okay. Totally different theorem. We'll leave that one there for a second, just to be this part, give myself some more room. Number 12, we're looking at a different kind of figure. Oops. Looks like this with triangle. Triangle, and then it's got another little dude shooting up through here. Okay. One, two, three, 4, 5, 6, 7, 8, and 9. Use the exterior angle inequality theorem to list all of the angles that satisfy the condition. So, what does the exterior angle inequality theorem say? What? You have it, but I didn't say the name of it, so now you're mad. Is that what we're talking about? What? That's crazy.
Actually, this
Is it?
on the next page.
So what does it say? I drew another little picture. We'll put that one on hold for a second. With angles 1, 2, 3, and 4. All right. What would it say about this? Which one?
I don't know if it's the right one.
Okay. Which one do you think?
So,
Okay. So see that this I gave this one is 1, 2, 3, and 4. Right. We're gonna put that on hold. Exterior angle theorem. No, just kidding. That's different. Exterior angle inequality. What does it say about angle 4 as it relates to angles 1 and 2?
It's bigger.
It's bigger. What it says? It says that like in this the way this one's labeled, it says that angle 4 is bigger than angle 1, and it also says that angle 4 is bigger than angle 2. Alright, so that's the theorem we're talking about. Did we talk about the exterior angle sum theorem in this lesson? Or is that the next lesson? I think that's the next lesson. Yeah, that's the next lesson. Great. Yeah, angle right side relationships, great. Okay. Yeah, we'll make sure we're in the right place. You're gonna learn another theorem that kind of like makes this one be even more obvious in the next lesson. But that's all this theorem says. So back to this problem. On number 12, measures greater than angle 8. Alright, so where is angle 8? Angle 8 is right here. Alright, so we need to figure out which angles are opposite exterior to angle 8. Alright, so let's start eliminating some angles. Right? So which ones is it not? What? It's not 1. It's like way over there. Alright, we're talking about this triangle. And that can be useful. Sometimes it can be useful when you come up with hit a problem like this, something where you're trying to isolate and be like, okay, what are we talking about? It can be useful to like quick sketch in the margins just that thing, right? So we're talking about this triangle, and that's all we have with it. So we have this angle, right? And then 7, and then 9, and then 6, and then, wait, I didn't draw that right. This is this one, right? That's some other thing over here. It's 3, and then 5, and then 4. The mistake that I made in drawing that sketch illustrates why this problem is tricksy. Because this extension line is a part of the triangle, but this one isn't. So angle 3 is not going to be it. Okay. It's not angle 3. It's not going to be 7 because that's one of the ones inside of the triangle. That's true. Or 6. That's also true. So 9 appears to be bigger, and it probably is, but we can't prove that with the exterior angle inequality theorem, right? Because it's not across from it. It's not over on the other side. So it can't be 9. 9 is probably bigger than it, and we could probably do a little bit of a proof to figure out that it was bigger than it. It probably is, but we don't know that for sure, right? So it can't be that. Now we're down to 4, 5, and 2. It is 2. 2 is one of them, right? Because it's on the same deal. It's involved this triangle. Like if I kill this and just keep this extension, it's not what? What are you thinking? It is. It is next to the triangle. Now is the tricky bit. So it is 2. So angle 2 is one of the answers. But it's not 4 and 5. It's only one of them. Which one is it? You had a 50-50 shot of guessing right, and you guessed wrong. That's all right. Thanks for playing.
I didn't actually do this one.
You're just like, I might as well guess that's that. Because, okay, cool. That's totally proof. And then, right, that is the justification because, no, it's not 4. How do I know it's not 4? I'm going to show you an easy way to figure it out in a second. But I want y'all to think about it for a second. It's not just because the key told me either. I like when I'm trying to think about this particular lesson and this one and the next one. Am I correct? Yes. No. Actually, the next one. Have we done the exterior angle theorem already? It's not in here. Y'all know what the exterior angle theorem is? I feel like that was in an earlier chapter or something.
Yeah, it was in like unit 3, I think.
Exterior angle theorem says that this one plus this one equals this one. Right? So when we're thinking about exterior angle of a triangle, it can be kind of tricky to figure out where they are. Right? And which angle it is and which angle it isn't. But if I extend the triangle out, if I extend all the lines, these ones are already extended, then I can get a figuring. Now that I've extended them out, what is the difference between angle 4 and angle 5 on the extensions? 5 is what?
I said 5 is opposite.
It's not, yeah, it's not opposite. What did the extension do to 4 that it didn't do to 5? Let me draw that part a little bit bigger and better. So just the top bit. I'm gonna just draw the top edge of the triangle to start. So here's the top edge of the triangle. That's the top edge of the triangle, right? What is drawn in the picture is this one keeps going. So this is the extension. This other extension isn't drawn in the picture, right? But there's another one over here, right? So that's the OG, right? That's the original picture. That and only that, right?
Somebody extended it.
No, yeah, somebody extend it. They probably were learning the same stuff. Alright? So that's the original in purple, right? And it was labeled as angle 5 and angle 4. This line is already extended, right? This one's already extended. If I want to extend this one from this triangle, I would add it in right here. What does the brown line do to angle 4? Y'all are probably trying to think too smart. It's a simpler idea maybe than what you're thinking. What? It's on the same line as that lower triangle. Well, what does it do to angle 4? It chops it, right? It cuts it. This extension already existed and it doesn't cut angle 5. Angle 5 is already a part of the triangle. So if your extension has to go out and it cuts whatever angle you're talking about, that one's not one of them. That's part of a different triangle. So that's why it's not angle 4. And it's only angle 2 and angle 5. What other questions do we have? There's one that I keep expecting y'all to ask about and you haven't asked about it. I may do it anyway, we'll see. Because there's one question that has extra steps. You might have figured it out, but you might not have. What? Why don't y'all look at the homework and figure out which one I'm talking about? Which one has extra steps? What? Not 20. Now 20 does has a like a word step, but that's not what I'm talking about. 18. 18 does have extra steps, kind of, but it's the same amount of steps as 22 has extra steps. How did you do 18? What did you have to do 18? Because it does have a little extra step. It's easy. It's simpler. They what? No, I went back. We'll get back to the one I was talking about in a minute. I'm talking about 18. What did you have to do? Because you have to do something before you can just write the answer, right? Like on number, whatever it was, like on number 15 or 17 or 16, you could just write the answer, right? And you just like, okay, that one's smaller, that one's next smaller, that one's next smaller. Done. 18, you got to do something first. What do you got to do on 18 before you can write the answer? find angle B. How would you find angle B? What do all of those angles in the triangle add up to? Not 90, 180. So 51 plus 71 plus the measure of angle B equals 180, right? What would you do to solve that? Add what? I can't understand you when you talk like that. Angle B is minding his own business. What am I gonna add? 71 plus what? 51, true enough. What's 51 plus 71? 122. Now what would I do? I would subtract. What would I subtract? 122 from both sides. That's true. Excuse me. What is 180 minus 122?
58.
It's 58. Right, and then you do it just like the rest of them, right? So the smallest is angle A, and then angle B, and then angle C, and then which means that the shortest segment would be the one across from A, so segment BC, and then the one across from B, so segment AC, and then the one across from C, so segment AB, right? All right, now what about 22? Because 22 is even more tricksy, right? It gives you even more things you got to do before you can solve, before you can just write the answer. Because it shoves X's in there. What? It is basically the same thing, that's true, but with X's. Yep. And an extra path, right? It is basically the same idea. Let's make sure we got it. 2x plus 1 degrees and 2x plus 9 degrees. How many degrees is that one? 90. It's true enough. So we set up the same thing, right? This plus this plus this equals 180. 2x plus 1 plus 2x plus 9 plus 90 equals 180. So what would we do now? We would combine like terms. Where are they? 2x and the 2x, and then the 1 and the 9 and the 90, right? What's 2x plus 2x? 4x. And what's 1 plus 9 plus 90? 100 equals 180. Then what would we do? Subtract 100. Four x equals 80. Then what? Divide them. X equals 20. Then we'd have to substitute back in and figure out what these are. What are the letters on this one? X, Y, Z. X, Y, Z. Put the 20 over here. 2 times 20 plus 1. What's 2 times 20? 40 plus 1 is 41. This is 41 degrees. Let's do math. Substitute it up over here. 2 times 20 plus 9, so 49 degrees. You could also just add these and subtract from 180. That would also work, right? So that's the smallest angle, then that one, then that one, which means this side, then this side, then this side, right? Easy peasy. Any other questions? The next lesson is, I think 5.5. I think I skipped 5.4. Triangle inequality theorem. It's not so bad either. There's some proofs in there. And then we'll do one more lesson talking about the hinge theorem and other two triangle inequality stuffs. Why don't we do a little bit of the study guide from the first couple lessons? So let's flip over to page 382. Okay, let's do number 11 from 382. If you've not started studying all the vocabulary yet, I would highly recommend doing that. It's a lot to remember. I know I've said that before, but want the best possible scenario. Find EG if G is the incenter of triangle ABC. What is the incenter? Yeah, there are a lot of centers of triangles, right? What is the incenter? It's the point of concurrency between something, right? Between what? Yeah, it is a point. That doesn't make any sense. What is the incenter? You may need your notes or the book or something. Angle bisectors. Point of concurrency between the angle bisectors. That's why I waited to draw it, right? I didn't want to just give things away, because we just kind of split this one in half. We draw a segment. We split this one in half. We draw a segment. We split this one in half. We draw a segment. And then those other lines, because it's got a bunch more lines, and let's talk about what those are and why those are. Right? So the incenter is that, and it says it's point G or something, right? G. That's what it is. It's where all of the angle bisectors cross. The incenter is the point of concurrency. Point of concurrency, right, that just means where they touch, right? Where all those lines cross. Where the angle bisectors cross. What is an angle bisector? That's an easy answer, right? What does bisect mean? Not cross. bisect mean? What does that prefix bi mean? Two. So to bisect means to cut in half, right? So those lines, the little line segments that I drew, they cut each one of those angles in half, right? So this angle is congruent to this angle, and this angle is congruent to that angle, and this one's congruent to that angle, right? That's what angle bisectors are. Great. G is called the incenter. Where all the angle bisectors cross. Great. What does the incenter theorem say? Because it tells us what's true about the incenter. It tells us what kind of relationships we can figure out. It is equidistant from what? Not to the vertices. So the angle bisector does cross through the vertices, and it cuts the angle in half, which is probably what you're reading. The incenter is equidistant from all the sides, right? Which may not be the incenter theorem. That may be the theorem before that. The angle bisector is equally distant from the other sides. There's a theorem that says that, right? So that's what those other lines are. That's why they drew those other lines. This one. The shortest distance between a point and here is going to be perpendicular. That's why these are perpendicular, right? And that one, and that one, and then that one. Our theorem says that this is the same as this, is the same as this. True enough. Find the measure of EG. Where is E? E is this one. I already said this was G, right? Of EG, if G is the incenter of ABC. So let's see, what else are we given? We're given that this is 13, and this is 12. So EG is over here, and it's far away from the numbers we're given, so that feels useless, but it's not, right? Because incenter is equidistant from the sides, so if we can get this one, then we can get the one we're looking for, right? We've got a right triangle here, right? Looks something like this, where this is 12 and this is 13. We know two sides of a right triangle. How do we find the third? We did this the other day. And it wasn't even the first time you've done it, I suspect. How do we find the third side if we know two sides of a right triangle? Pythagorean. A squared plus B squared equals C squared. Which one are we looking for? A, B, or C? It's somewhat of a hint, but it could be either one of two. There's two possible answers to my question. It's either A or B. Which one is C? How do we know it's C? What? Which one is C? This side, or this side, or this side? It's not this one. So it's got to be that one, process of elimination, right? How do I know which one's C? Which one is C? He's got a fancy name. What is he called? Hypotenuse. He is the hypotenuse. How do I know which one is the hypotenuse? there's two things that tell me it's a hypotenuse. One, I don't know yet technically, but the other one I do. Let's pop a few other right triangles on the board so we can understand what's happening. Whoa. That was a curved straight if I ever saw one. That's closer. Alright, I labeled the hypotenuse on all of those triangles. So how can I tell that those are the hypotenuse? It's what?
The side that doesn't have the right.
Yeah, you can think about it that way. So the side that's not touching the right angle is the side that's across from the right angle. It's also the longest side. It's also always the longest. So this is the one across the right angle, that's the hypotenuse. C is the hypotenuse. That's the only one that it matters where you put it. A and B can flip, right? Because the commutative property. Right? But the hypotenuse has to be C. So, this is 13. What's 12 squared?
144.
144. What's 13 squared? Y'all have calculators.
169.
It is 169. And we would subtract, right? So what's 169 minus 144?
25.
It is 25. How do we get rid of that squared?
This thing. Square root.
We do square root. Hey, Lucy. Your cousin's here. Anyway, yes, you take the square root of both sides. Now, I said the other day, and I will continue to say these words, that when you take the square root of both sides, you have to remember that it's plus or minus for next year. But we're talking about distance, so it can't be negative, right?
Wow.
So we're going to throw out the negative. So A equals 5. Technically equals plus or minus 5, but we don't want that one because we're talking about distance, so it's 5. And if this is 5, then this is 5. So the measure of segment EG equals 5. Bye now. Goodbye. Okay. I would look, if I were you, I would study starting yesterday or now, if it hasn't happened before now. And I would make sure you have all the vocabulary pieces memorized. I would also look at the examples in this study guide, the ones with the in-center and the ones with the central and all that stuff. I would make sure you got that. And if you don't got it, ask about it in class or outside of. Because do this.